In this video, I'll talk about the architecture of web applications. So how do we structure our code, and how do we structure the computers that run the code? Now, imagine you're creating a large website. Let's say it's a new social network to rival Facebook. This website could have tens of thousands or hundreds of thousands of lines of code. Now, one approach to implementing it could be to have everything in a single supermassive servlet. The single servlet that does everything, that contains every line of code in a single method that runs on just one computer. Is this a good idea? Well, obviously not. But why not? Can you articulate the reasons? It would be technically possible to design your code that way. The computer doesn't care. But people and teams need structures and well-defined boundaries to work together and manage complex systems. It would be very difficult to fix bugs in this supermassive servlet. It would be difficult for more than one person to work on it at the same time. It'd be hard to understand what everything does. It may be technically possible, but it'd be very impractical. So what are we trying to improve when we talk about design? Well, we want the system to be maintainable. It should be easy to make changes. We want it to be testable. It should be easy to identify and fix bugs. We want the system to be affordable. It shouldn't cost too much to build or run the system. We want it to be understandable. It should be easy for new developers to join the team. In addition to the quality of the code, there are also performance concerns. A single servlet running on a single server is probably okay for a small site, but if you have thousands of simultaneous users, or lots of computation that needs to be done for each user, then you're going to need to find solutions to performance challenges. We want the system to have high throughput, low latency, low response time, high scalability, high availability, and high reliability. These are just some quality attributes that we'd like our system to have. With these attributes in mind, you can start thinking about the various trade-offs that you need to make in designing a system. For example, to improve maintainability, we could start by trying to split up our supermassive servlet into separate packages or modules. When we do this, we not only want to split it up, but also start grouping related things together. If we've grouped things together well, and we've designed our systems well, then a small change in the system requirements should only require a small change in the code, all in one place. One of the most common high-level strategies for the architecture of a web application is layering, and I've already hinted at it in other videos. A layer is a collection of classes that work well together and that have minimal dependencies on other layers. Layers typically build on one another, so that a higher level layer depends on lower level layers. Each layer creates high level abstractions and hides implementation details of the layer below. There are many different layering strategies with different numbers of layers and different names. Right now, I'd like to look at a simple 3-layer architecture. In this architecture, we have 3 layers. Presentation, which is responsible for generating the user interface, laying out the forms, gathering user input, displaying images and fonts, and so on. Domain logic is responsible for the business logic of the application. What does the application actually do? Why does the application exist? Data source is a layer responsible for storing and retrieving data. This is what communicates with the database, the file system, or whatever other place the application stores its data in. So if we're building a website to rival Facebook, the presentation layer is all of the HTML generation code. It would include code that generates the buttons to befriend users and to like posts. The domain logic would be where all those functions for friending and liking are actually implemented. This is the real meat of a social network application and would be used by the web interface, but also a mobile app and perhaps even a desktop version of the app. When the like button is clicked, the presentation layer will forward the request to the like function in the domain logic. The data source is responsible for storing all the user data and post data. It would have functions to create and edit records of users and posts, and the domain logic might use the data source layer to retrieve details of a post and then save an updated record where the like count has been increased by 1, for example. In addition to the logical structure of an application, there's also the physical distribution of the code. We have 3 logical layers, but they could all be run on one server, or they could be spread over 3 or even more servers. When we spread these layers over separate computers, we call it a tier. So a tier is essentially a layer of physical computers. Now the simplest case is just a one-tier architecture. We have a single, self-contained client application. That one tier contains all 3 layers of the application. Now obviously this is very simple and self-contained. There's no need for a network, there's no need for a server, but that's also a disadvantage. There's no sharing of data, there's no sharing of resources. It's difficult to maintain, it doesn't scale, and it certainly isn't a web or a network application. Now things get more interesting when we take advantage of the network. A 2-tier architecture, or a client-server architecture, splits the application into 2 physical layers. We might have a database running in a central location, then each user runs a powerful desktop application that uses the central database to store data. This gives us the benefits of shared access to data and a relatively simple architecture. However, the downsides might include the difficulty of keeping the client and the server in sync, keeping the code in sync, as well as the difficulty of securing the database if the client applications are sending low-level SQL. Perhaps we could also move some of the domain logic to the server. This would help overcome some of the limitations of security. So we could authenticate actions inside the domain logic rather than passing raw SQL. And we can ensure that the domain logic always stays in sync with the database. However, now our server is responsible for almost everything. And this could create problems with a single server doing too much work when we have lots of users. So the obvious next step is to split those tiers again. Here, we've moved the domain logic to its own layer. We've split the load over several machines to improve scalability. In addition, the very act of imposing this kind of physical separation will have consequences in our logical application layering. By forcing the code to be run on separate systems, it will help improve the logical layering of our application. Of course, as we do this, the downside is that we're increasing the complexity of the solution and we're adding more chances for the system to fail. Another advantage of a multi-tiered architecture, such as this one, is that we can start adding machines to each layer to improve scalability. Suppose we have our data in 3 separate databases or data sources. Now, in a 2-tier architecture, if we have 100 users, we'd need 300 connections, so each user would connect to each of the 3 data sources. 3 times 100 is 300. But in a 3-tier architecture, you only need those 100 connections to the application server, and then 3 more connections from the application server to the data sources. So a total of just 103 connections. You've eliminated almost 2/3 of the number of required connections. We can of course keep going. An N-tier architecture refers to an architecture with more than 3 layers. This diagram depicts a simple N-tier web application. Because the client is a web browser, we need some of that presentation logic to be run on the server, the web server. The web server might make use of application servers to handle the domain or business logic of the application, which can in turn make use of multiple data sources. We can keep going, and the advantage of an N-tiered architecture is that we're able to build powerful, scalable, and reusable distributed applications. However, the downsides are obvious. The more complex the architecture, the more difficult it is to build, maintain, monitor, and manage. Going beyond 4 tiers, a complex N-tier architecture could use many components and services. For example, load balancers and firewalls could help manage the incoming traffic. Caches and content delivery networks could save responses and avoid continual recalculations. Directory servers could simplify management, and billing and email gateways could help reduce the complexity of the application code. So a sophisticated web application could use many components in many tiers. Which architecture should you use? Well, it depends on the situation. If you need something simple, you might just use a 1-tier architecture. If you've got a web browser, then this is by definition at least 2 tiers because you've got 2 machines, your browser and the server. But from there, it's a process of striking a balance between complexity and the need to deal with large volumes of traffic. Fortunately, the Java EE specifications will help you deal with some of the complexity. Here are some of the services that a Java EE application server provides. You may recognize some of them as being part of a multi-tier architecture. In fact, we even classify some of these technologies as being designed to support the layering and tiering of your applications. A Java EE application server is not just a web server, but it also provides a wide range of tools that help you implement your domain logic and interface with data sources in a clear, clean, and well-designed layered architecture. Now, I've only scratched the surface and have simplified things a lot. If this is interesting to you, then I recommend taking a look at websites such as highscalability.com. This is a fantastic resource for learning about how real-world systems have been made to scale to millions of users. I've talked about many things in this video, and all are important to understand. But if there's just one main point, it's that the very first architectural strategy you should apply in your application is the layering of your application into 3 layers: presentation logic, domain logic, and your data access logic. This will help you with maintaining your application over time, distributing it into physical tiers in a multi-tier architecture, and also allowing multiple developers with different skills to contribute to the one project.